We're going to talk about food and technology and some of the new things on the horizon. Here is the bad news. This is a little data chart that shows human population over the last 12,000 years. And it takes a couple of minutes, but it's worth watching. Let me talk over it as you look. It's kind of fun that, 10,000 BC, Mexico was where everybody lived. And that still sounds pretty good if you look at the beaches. Here we're going and going. We're getting up into 4,000 BC, India and China. And one of the things to watch on this whole thing, watch what's going on with China. Watch how population expands, goes down. Now, the scale keeps increasing, so worldwide we're getting more and more people. We started out with about 2 million humans on Earth there at the beginning. At one point we had been all the way down to about 1,000, maybe 2,000 humans, but that was back 76,000 years ago. Here we're coming up into sort of modern prehistory. And again, watch China. This is a good explanation whenever people say, why does China do some of the things it does around food and population and security? If you have a history like this. Back and forth, everybody jockeying for position, getting up in the now billion threshold. We're about to cross and have crossed it. 1 billion human beings on the planet. And then it keeps going and going. We get into the modern era. And it's good that we've gotten here, but this is the bad news. 7.5 billion people on the planet. We reach peak humanity in about 30 years, not quite hitting 10 billion people on the planet. Why does this matter? Because we need to grow as much food in the next 30 years as we have grown in the entire history of what I just showed you. Let me say that again. We've got in the next 30 years to grow as much food and feed as many humans as we have done all the way back through recorded history for humanity. And we've got to do it in 1/400th of the time. Okay, so challenge accepted. Now here's the good news. We've got some technology that can help us. And we've actually done this before. We've gone through the Green Revolution at least one time. Norman Borlaug was actually one of my teachers at Texas A&M. And I should mention that I'm a little bit of, one, an Aggie, and two, a Texas boy and a farm boy. And I worked knee-high to my grandfather and the cattle ranch. And so I've got a perspective on this. But we're looking at this now and we're knowing that we have technology that we can use for new sensors, things that we can do with animals and plants and some things that are not animals and plants. And I want to talk to you about that really quickly in the time that I've got today. So talking about sensors, everybody comes up with this idea that we're going to have massive weather stations on each acre, that we're going to go ahead and have drones and robots. And I think we will have all those things. But as someone who has helped do the books for a ranch, those are really capital intensive pieces. We will have that stuff, and especially on larger and larger spreads, this will be something that is done, and all that data, that big data, will feed into AI and be analyzed. But we're going to see some things first, and I think might have the bigger difference, like this. So we actually have Tim Cannon here today, who's both one of my favorite biohackers and one of my favorite founders of a company. Livestock Labs makes a chip to go into cows to monitor what is going on with them, what's going on with their health, their performance, their location. And I'll let Tim talk about it because he'll do a better job than me doing it secondhand. But a fantastic company and a really good way to leverage some of this exponential technology. Here's another one. Canethus is a company that is looking at and has actually succeeded in using even cheap web cameras to monitor livestock. They can basically do facial recognition on cows. You don't even need to tag your cattle. And part of the idea here is cattle are prey animals, and humans, we're predators. And whenever we're in the same dairy barn or locale with a herd of cattle, they're nervous and they're edgy, and you can actually see yields decrease the more people interact with them. The ability, because we've got now these new AI-backed visual systems where you can just put a camera up and have it record all the time and feed this into a computer back-end that analyzes the footage, you can track which cow is more aggressive, which cow is eating enough or not enough. You can do things like gait analysis and predict before a human veterinarian can when a cow is going to need some medical attention, is starting to have some problems. So this is a nice little bit. And like I say, the front end for the system is just a camera. And we're going to see more and more things that are driven by a camera and a computer. We're also going to see things that are driven by a little bit of a fancy camera. So this is another one of my favorite companies. In full disclosure, I'm both an advisor and an early investor. And what they're doing is they're going ahead and using hyperspectral imaging, which used to be something that was a $200,000 camera that you could only afford to put on a satellite. And now that price has been coming down. The founders have predicted what this price curve would do. And you can use this to look at food that is harvested and get some idea of food safety, get some idea of taste and quality and ripeness. And again, the CEO, one of my favorite people in the world, Abby Ramanan, is here today, and she'll be presenting on this at 1, so don't miss it. So this gives you an idea of what is going on with sensors and AI and some of the possibilities there to go ahead and gather data and use this to increase yields, use this to go ahead and head off problems before they start. We're also doing a lot with plants. This is something that remains in the market a little controversial, but we'll talk some more about what that looks like and how that's different from region to region and nation to nation. But we're starting to see this idea of GMOs, genetically modified organisms, especially in crops and feed, be replaced more and more by the idea of gene-edited crops. And the distinction here is a GMO is sort of our old-fashioned, if you can say that about genetic engineering, thing where you've gone ahead and taken DNA from another organism or a new sequence of DNA and put it into a standard livestock chassis and done something. And there are concerns about, could you cause an allergic reaction? Could you do something to the environment? None of those concerns have ever actually come true. This remains one of the safest technologies humans have ever invented. But with gene editing, we don't even have those theoretical concerns. The idea is we turn down or turn up some trait that already exists in the animal or the plant. So that is also regulated in a different way. And the other thing, and the reason I call this GMO 3.0, is we're moving beyond just this simple thing to say, here's somebody who wants to increase yields by being able to use more pesticide and more herbicide, being able to stack traits. We're starting to see ways where we can go ahead and change the traits of these crops so that we can use them to ride more lightly on the environment or grow in places that they wouldn't have been available to grow before, be in entirely different biospheres, entirely different locales with different weather patterns, different soil salinity. The other thing is we're now editing in traits that are not something that you kind of like, can we sneak this into the cereal and hopefully nobody is worried about it? It's something that you proudly advertise. These are consumer traits. And let me give you just 2 quick examples of this right now. So this is a soybean, and there are a couple of interesting things about this. It is a soybean that is drought resistant. One of the big problems in the soy industry is whenever you have a bad weather pattern, you have a bad year financially. In the 3 countries that this has been approved for use in, it's estimated that it's going to save $5 billion a year, where farmers will be able to grow the soy to maturity and get it to market when they couldn't have before, and it'll head off that many losses. The other thing that's interesting about this is not the product of a big traditional American company, somebody who works in this. This is from Argentina, a little company called Bioceres. And they've actually got a whole list of things that they're working on next. So this is one example. Here's another one, and this is more of a consumer-focused bit. This is the Simplot innate potato. How many people have ever seen this one? A couple of folks. The idea with this is that as compared to a standard potato up here above me, you can go ahead and have this potato, and whenever you chop it open, it doesn't get brown. It can sit around. It's a consumer trait. It's something that will help if somebody's a food preparer. It's also less bumpy. It doesn't have as many eyes. It doesn't have as many little hills and valleys. It's easier to peel. And probably my favorite thing about this, you know how you hear that thing where you put a steak on the griddle and it gets black and they're like, oh, you better not do that. It's going to give you cancer. You hear the same thing about your French fries. There's a reaction that occurs with this amino acid complex. Whenever you fry things or burn things, it makes acrylamide, and that's a known carcinogen, and it's not really what you want in your French fries. And I always want to say, this is the first potato where you can make French fries that are good for you. It's the first potato where you can make French fries that are much less bad for you, that won't give you cancer, we'll say that. So this is the kind of thing that has been done by gene editing, turning a few traits up and down, and gives you an idea, an example of what's going on. In the animal space, I wanted to just talk about 2 quick stories to whet your appetite for some things we may talk about later. One is this pig, and I'm promising you I'm not going to show you a cute piglet and tell you about the pork industry and all the bacon that we're going to make from this guy. This is actually a research animal. There was the Beijing Genomics Institute came up with this idea. They said, you know, whenever we study human nutrition, our best model animal is a pig, because, all joking aside, the digestive system of a pig is very similar to humans. The problem is those pigs get really big and take up a lot of space in a research lab, take up a lot of food. And their whole idea was, wouldn't it be great if we could go ahead and tweak a few genes in the pig so that it never grew up? And at one point, these were called Peter Pan pigs. And I love this idea. This is kind of how they roll in China. They're just like, let's do it. And they were able to make this happen in just a couple of years. And then 2 years ago, they rolled this out at a scientific conference. And people lined up all the way inside the convention hall and outside the building and around the block to get selfies with the little micropigs, is what they call them. So by the end of the day, the Beijing Genomics Institute, BGI, said not only will we have research animals, but we will also be selling these as pets. And again, this is a very Chinese way to do it. So, interesting piece. Now, here's another one a little closer to home and practicality. We're actually seeing this as a project at UC Davis that I had been privileged to have a little part of. People working on making hornless cattle, cows and bulls without the horn. And I remember as a little boy having to go do that thing where we would actually surgically remove, which is a nice way to put a fairly rude and painful procedure, or chemically burn off the horn buds. Now there are cattle that are born just without them. And this cuts down on injury, cuts down on problems with herds, both beef and dairy. And so it's a nice, interesting piece that we can do this. And then we're looking, as a couple of people have already mentioned, can we even have our meat industry without meat? The Impossible Burger. And you've heard a lot of things about the Impossible Burger. Here's something to remember. It's now in 4,000 plus restaurants worldwide. I was flying over on Air New Zealand and they want to serve me an Impossible Burger. I said, oh, the Prime Minister's not going to like this. But you heard that already. I had a chance to actually go to an event, and this was a little bit of a secret thing at the time, In January in Las Vegas at the Consumer Electronics Show, Impossible Burger rolled out their Impossible Burger 2.0, because it's not even a recipe as much as you could kind of call it a program or a data program, where they're gathering data on how do we produce this, how do we source the ingredients, what are the different taste tests. I've had Impossible Burgers before, and like I say, I'm a Texas boy. I like my beef, I like my steak. The 1.0, you wanted to get it medium, maybe medium well. You didn't want to let it get cold before you ate the whole thing. The 2.0 is a whole step above, and it's going to be slowly rolling out to more and more restaurants and places, and it's, I think, a game changer, and it's a wake-up call. So this is an example of what we call cellular agriculture. And to go into this just a little bit, the idea here is, can we make meat outside of an animal? And I show my little boys, I've got 12-year-old twin boys, I show them this diagram, and they say, "Daddy, you can make meat without hurting animals." I say, "Yeah." They say, "We're pretty sure you're hurting that pig right there." I go, "What do you mean?" They go, "That big chunk there, Band-Aid's not gonna fit over that." I said, "It's a bad diagram, that's an old way to do it. We never did a big chunk like that. We use a syringe and we get cells out." And they go, "So the pig gets a shot?" I said, "Yes, the pig gets a shot." "Daddy, we don't want the pig to get a shot either." I was like, "Listen, do you want the pig to get a shot and we take the cells and it lives 20 years and has a Facebook page? Or do you want bacon and you gotta go ahead and deal with the pig trauma?" They're like, "Pig gets a shot." So that's what we do. We withdraw the cells, we go ahead and make a cell culture, sort of a cell slurry, and then this is where the real work and the art is. We encourage those cells to grow into sheets of muscle with vasculature so that it can scale and get bigger. And there actually ends up, because this is muscle, there's sort of a little electrophysiology Pilates machine in there. You don't want the flabby bacon, you want the good bacon, right? It's a muscle. And this is something that's done without any genetic engineering. It's just a new way to grow the cells, where you don't kill the animal, where you don't feed an animal for 6 months or 3 years or 7 years, depending on what we're talking about, and then kill it and throw away 40 to 60% of the carcass, and you don't have all of the things going on with the environmental impact and the other pieces. So if you want to do a little genetic engineering, you can turn down the cholesterol, you can eliminate lactose, you can do some different things like that. And this is the state of play with cellular agriculture. I used to show just this one picture of Mark Post. He's on my faculty at Singularity U. He's in the Netherlands. He's one of the first people to develop the lab-grown meat patty. And there were two things about this whenever it came out in 2013. One was a little bland, it needed some salt or something. It wasn't very fatty. But the second one was, it was $330,000 US to do this first one. So it's, you go to McDonald's, you get a bridge loan, you sit down and have some fries. Not gonna work out. Now, 3 years later, he's got this down in the thousands of dollars range, and he's joined by a number of companies that are working on chicken, beef, fish, leather, that are working in several different areas. And in fact, what we call cellular agriculture comprises at least 3 different areas, and we'll talk about that later. And then what is interesting now is he's saying, now 3 years after this, they're within striking distance of being able to deliver a consumer-priced beef patty with a really good taste and a really low and scalable price. And this is what the state of play looks like for companies that are in this space. 3 years after this, in 2021 or 2022, we already are having today companies now deliver consumer products at consumer pricing. We're expecting to actually see large-scale beef, dairy, other things. What does that mean? I wanted to highlight at least a couple of other things. You guys know about New Culture based in New Zealand? So you've got your own cellular agriculture based on making cow cheese, and not vegan cheese, but really good cow cheese, but without involving the cow. And here's another one, and this is not just now we should all take a shot. This is a company called Glyph, making Glyph molecular whiskey. And to give you an idea, this is what they did. They analyzed in extensive detail 30-year-old sherry barrel-aged whiskey that sells for $2,000 and $3,000 US a bottle. And they said, we can do that. We'll source these ingredients, we'll grow these other things in bacteria, and overnight, they can make a 30-year-old barrel-aged whiskey. And they sell it for $50 a bottle. And I'm a little bit of a teetotaler, so you don't want to ask me, but the worst that I've heard at whiskey tastings that we've hosted from people who really know what they're doing and drinking is, this is surprisingly good. And the best is blind taste test. I can't tell the difference between this and the really, really good, expensive stuff. Now, I'm not saying that, and this is kind of a metaphor for what's going on too with beef. I'm not saying this replaces the old thing. Not everybody's gonna want it. It's not that big a deal. People who want the price or they want a specific experience will do that thing. But what does this do to other markets? What does this do to authenticity? What are other things we're gonna see? So, that's what I wanna kinda ask you guys. And this is some of the things in our workshop later today we're going to address. What's going on with how much protein we need in the world? We're gonna have enough calories. Will we have enough nutrients? Will we have enough protein? Will traditional agriculture be replaced? And the quick jump to the end answer is no. We're gonna need everything that we've got to get through this next 30 years. And then I wanna do, if we can do an interactive thing in this workshop later, a little bit of a thing about radical transparency and how do you market cellular agriculture and how do you market against it? And I'll tell you actually my best things that would beat up cellular agriculture, the things that you would not want a consumer to hear because they'll never want to taste one of these things. And looking at that, and we'll see how other industries have overcome some of this. And then what happens, because the big dog in the room, as we saw on that chart at the beginning, and as we've seen more and more with agriculture and food imports, is China, and that's just gonna be our reality going forward. I appreciate you guys taking the time to listen to me today. I got a few things up here. The most important one is this email address, slides@raymondmccauley.net. If you'd like to get a copy of these, including all the details and the references, I'll be happy to send it to you. Thank you so much.